So today we're talking about correlation coefficient, and we're also going to be talking about the regression line, okay? So the Pearson product moment correlation coefficient, that is the official name for it, and it's represented with a lowercase r, okay? So if you ever asked to find, it's lowercase and it's italicized. So if you ever ask us to find r, then they mean for you to find the correlation coefficient. Now what it is used to know the strength of the relationship between any two sets of data that are thought to be related, okay? So you know how we can comment on something being strong or moderate or weak. The correlation coefficient basically gives us a number to help us associate whether or not this is indeed strong or moderate or weak. Does that make sense? Okay, so again, it's the numerical value, and it's between two sets of data that we think might actually be related, okay? So R can take on values between -1 and +1. Okay, so when you find the correlation coefficient, it's going to be a number that falls in between those two. It can equal -1, it could equal +1. If R does equal -1, then that means we have a perfect negative correlation between the two sets of data. That basically means that if we were to draw the line of best fit, that means that all the points of the data would go on that line perfectly. If we have R equals 0, that means there's no correlation at all. And if R equals 1, that means we have a perfect positive correlation between the, let's just say, data sets, okay? All right, now, if R is between these particular values, then this is exactly how you can determine if it's very weak, moderate, or strong. If we fall between 0 and 2.5, that means we are very weak. If it's between 0.25 and 0.5, is weak. If R is between 0.5 and 0.75, then that means we're moderate. And then if it's between 0.75 and 1, that means that it is strong. Okay? Now, these same numbers, these same intervals also apply to the negatives. Okay? So if it's between 0 and -0.25, that still means it's very weak. It's just very weak in a negative direction. If it's between -0.25 and -0.5, it's still weak. It's just weak in a negative direction. Are you following along? Okay. Good stuff. Now, to find your correlation coefficient by hand, I am going to go over this. I am going to show you how to do it by hand, because if you decide to do an IA that is statistics-based, and you decide to see if there's a relationship or a correlation between whatever two pieces of data you have, in your IA, you actually have to show the algebraic mathematical process in your paper. There's no calculator process, no second step, whatever. You actually have to do it by hand. So I'm going to show you how to do it by hand. For the exam, it's the calculator way, because it is a longer process and it's a time type thing. So on the exams, you need to know the calculator way. So I'll show you the calculator first. And then the last example we do will be by hand, so you can see it. Okay? Yes?
Does that go for an EE as well?
That goes for an EE as well. Yes. Okay? So, by hand, this is the formula. S sub xy, so these are subscripts right here, divided by S sub x times S sub y. And what are S sub x and S sub y and S sub xy? Are these respective formulas. I'll give you guys a moment to write these down. Make sure you're copying them down correctly, or it's going to throw everything off. You do it. All right, so what do all these symbols mean? So this right here means the sum, okay? So basically what you're going to end up doing is you're going to take your x value. So the data is going to be given to you, okay? You have an x value and you have your y values. You'll need to figure out what the mean is of both your x and your y. And what you'll do is you'll take every x value subtracted from your mean, and every y value subtracted from your mean, and multiply them together. Then you'll divide by n. N represents the number of pieces of data you have, and then you add them all up together. That's what that is. Down here, you take the square root of the sum of those differences squared, divided by n, and same thing with your y's. We will do one by hand, and it's going to be nice and organized in a nice little chart. This is a lot easier if you organize it in a chart format versus just trying to do it and put numbers and everything everywhere. I've seen your test. Organization is key if you plan to do this for an IA. Okay? So here we go. We're going to start by calculator first, because everybody has the calculator out. And this is how I expect you to do it for your homework, and how I expect you to do it for your test. However, for your IA, the by-hand way is what I want to see. The data given for the first division football league show the position of the team and the number of goals scored. I know score is spelled wrong. Don't say anything. Find the correlation coefficient R and comment on its value. Now, if you have to comment on the correlation or comment on the relationship, what words do you think you should use? Positive, linear, negative, strong, weak, moderate. So if it ever says, write a sentence about the relationship or comment on the relationship, that's what that means. Relationship. How do they match up? Are they strong? Is there a strong relationship? Negative, moderate, et cetera, et cetera. So when you went to look at your notes, if you were wondering why you didn't get that point, that was why. So here we go. Positions are X, our goals are Y. So we'll go into our calculator. This deals with statistics, correct?
Yeah.
So we're going to need to go to just regular stat. You press the stat button, and you go to edit. And what you need to do is you need to type in your X values into L1, your Y values into L2. Okay? I'll say that again. You need to type your X values into L1, your Y values into L2. Remember, you can clear a table by pressing clear and enter. Clear and enter. Okay? So go ahead and type in the data. Be careful. Make sure you get all your X's in L1, all your Y's in L2. So you should have your data in. Now, what you need to make sure that you do, the processes that we're about to go through, it won't always show your correlation coefficient unless your diagnostic is on. And I'll say that again. In order to figure out what your correlation coefficient is using your calculator, you need to make sure your diagnostic is on. When a calculator gets reset, like what they'll do on the day of your exam, they'll reset your calculator, the diagnostic is turned off when you reset. So you always got to turn it on or make sure that it is on. So this is how you do it. Everyone paying attention? Okay. You press the second button, and then you press the 0 button. And if you see right above the 0 button, it says catalog. If you ever forget where anything is, you can always go to the catalog and find it. It's like it's like the index. Okay? Now, we need to turn our diagnostic on. Diagnostic is D. So you want to go to the X to the -1 button. You see there's a green D right there? You just want to press X to the -1 because it's already in alpha mode. So just press X to the 1. Okay. You press X to the -1. Did everybody press X to the -1?
Yes.
And you want to scroll down to where it says diagnostic on. So scroll down. Once you click X to the -1 and find diagnostic, that's DI. Okay? There's off, there's on. You click enter, you click enter again. Once it says done, that means your diagnostic is on. Okay? So now when you go through the process to find your correlation coefficient, it'll show up. So this is what you do. This is how we have our data in there, yes?
Yes.
Because mine shut off. That's still the data, right?
Yes.
Okay. So you'll go to stat. You'll go over to calc. Remember, this is where we went to find our mean and Q1, Q3. Well, we're going to go down to option 4, which is LinReg. So we'll press stat, over to calc, go to option 4, and LinReg. Now, raise your hand if your calculator looks like mine. So no one's calculator looks like mine, so this is what you guys are going to need to do, because you now have LinReg, parentheses or no parentheses? Parentheses. So what you need to do is you need to let the calculator know, hey, I need you to do this for L1 and L2. How do you get L1? You guys remember? Second 1. Then L1 pops up. Then you need a comma. And then you need second 2 for L2 to pop up. Okay? And then you'll click enter. For those who calculators looks like mine, clearly my X list needs to be my L1. My Y list needs to be L2. I don't have an L3. Save that for later. And when you guys press enter, did this show up?
Yes.
Okay. And R is on your screen, correct?
Yes.
That R is the same R as of your correlation coefficient. So then we'll round to three significant figures, and our answer is going to be negative
0.816.
So there's our correlation coefficient, and we need to comment on its value. Well, we can say it's definitely negative, and it is strong because it lies in between that 0.75 and that 1 category to make it strong. And now you find your correlation coefficient. Well, the option that we chose to find the correlation coefficient was linear already. So we know this is going to be a linear correlation. We already know that. Yes? Okay. Moving forward, okay? We're going to be talking about the regression line, okay? So this is like a set of notes. So you have a new goal. Make sure you write down the goal. You guys are now going to be finding the line of best fit more accurately. That's what the regression line is. It is a version, a more accurate version of the line of best fit. Okay? Yes, sir. Yes, of course. Your goal can always be your line that fits better. Yes. There we go. So again, it's the better fit line. Okay? It's the line that fits better. Okay? Now you should only calculate a regression line if there is a strong or moderate correlation. It has to be strong or moderate in order for you to calculate a regression line. Now, if it's weak, very weak, or if there's no correlation at all, then there's no need for a regression line. Only for strong and moderate correlation. How you do it by hand, that's the formula you need there. That S sub xy and that S sub x are the same ones from your correlation notes. Okay? And of course, the X bar and Y bar are the means, okay? S sub x is the standard deviation, and S sub xy is the covariance. We'll talk about those words a little later. There you go. Again, do they expect you to find the regression line by hand for your test? No. For your homework? No. Your IA? Yes. Okay? But I'm going to show you how to do it with your calculator first, because that's the one that you'll use the most. Okay, some of you all might even do a statistics-based IA. However, I will make sure you have the resource if you decide to do it. Anyone has it down? So, here we go. The table shows the number of mice for sale in a pet shop at the end of certain weeks. Okay? So we have our weeks, X weeks, our number of mice. We need to find the correlation coefficient. I see some of you guys already started. What do we do?
Edit. Gosh, you're your boy.
Edit, because I got to replace my data. I got to put in the new data. Remember, if you go up to L1 and press clear, it gets rid of all the data in that column.
Press delete.
Do not press delete, or you have to get it back. We're putting our weeks, our time, our weeks into L1, our number of mice into L2. Always make sure that your columns match up with the same number of data. Okay? Okay. Where do I go from here to get the correlation coefficient? Stat.
Yeah.
Count.
And 4.
Option 4.
L1, L2. L1, comma L2.
L1, comma L2. For me, it's already there, nice and neat. And press calculate. Did everyone get this for their R?
I got 9-7.
So, hop round to 3 significant figures. That would be 0.990.
Archie got a 1.
Okay. Now, part B says, find the equation of the regression line for x on y. That just basically means find the regression line. Lines are in the form of y equals mx plus b. you still have this on there, correct?
That's right.
Yeah.
There it is. There's y equals mx plus b. Instead of an m, it's just an a, but b is still the same, okay? When you find your correlation coefficient, you have found the equation for your regression line. It's right here. A represents your slope, so you'll use 3 significant figures, and b represents your y-intercept, and you'll use 3 significant figures there. All you gotta do is write it, okay? X stays x, y stays y, because it's an equation. So our answer for b, if I round a and b to 3 significant figures, it will be y equals 4 point what? 63x
Plus 30.9.
30.9. And that's our answer for b. That is the equation of our regression line. Simple enough, yeah? Okay. Now C says use your regression line. So even if you got the regression line wrong, this is where you can get follow-through points. Because it says using your regression line, the one you came up with, predict the number of mice for sale after 10 weeks. 10 goes in where? For x. Because we're looking for the number of mice, which represents y. So for part C, all we're going to do is take our equation and plug in 10. And because it said to take our equation, the equation we wrote for part B is the equation that we use for part C. Okay? So then you plug that in, and we'll get our number of mice. So go ahead and figure that out. So when you plug it in, you say you get about 77.2?
Yes.
So how many mice is that?
77.
It's 77 mice. Very good. Okay? All right, now part D says, can you accurately predict the number of mice after 20 weeks?
Yes.
Yes? Okay. So, this here. Can you accurately predict the number of mice after 20 weeks? What we have here for our data only gives us up to week 13. We don't know what happens in week 14 or 15 or 16 very yet. What happens in week 20. That's true. Something could happen and all the mice die. Or there could be, I don't know, a crazy boom and it just shoots up exponentially. Okay? So we actually cannot accurately predict how many mice there are after 20 weeks because we do not know what the data was after week 13. Exactly. Now, if it asks us, can we accurately predict the number of mice after 10 weeks, could we do that?
Yes.
We could. Oh, we did. I'm sorry, 12 weeks.
Yes.
Then we could. 13 we could. But anything after 13 we could not. So no, because after week 13, we do not have any data. Never just say yes or no. Always provide an explanation. Okay?
Why?
Why what?
Why do an explanation? That takes
You don't really